In 2003, China's high-speed rail network stretched to an impressive 28,000 miles, a marvel of modern engineering that captured the world's imagination. Yet, in just over 2 decades, this network has expanded to an almost unimaginable 999,000 miles by 2024. Amid this breathtaking transformation, one project towers above the rest, a railway that cuts through the very heart of the Tibetan Plateau, defying nature's most formidable challenges. This is the story of China's most daring railway project, a venture that redefines the limits of engineering and reshapes the future of a region known as the roof of the world. Tibet, an ancient land of breathtaking beauty and profound mystery, is as formidable as it is enchanting. Encompassing 463,000 square miles, this autonomous region is home to only 3.6 million people, a sparse population averaging 3 individuals per every 4 square miles. Despite its majestic landscapes, dominated by the towering Himalayas and vast, windswept plateaus, Tibet has long struggled with economic isolation and underdevelopment. Even with the highest per capita government spending, invested heavily in healthcare, social welfare, and job creation, the region's GDP lingered at a modest 239 billion yuan, roughly $34 billion, as of 2023. It is in this challenging context that China's visionary engineers sought to create a transformative lifeline. The journey began in 2014, when Chinese authorities embarked on a project unlike any other, a railway designed to conquer an environment where traditional construction routes simply could not exist. Unlike earlier projects that capitalized on relatively forgiving terrain, this new railway had to navigate some of the most hostile landscapes on Earth. With a staggering estimated cost of $50 billion, the project was not just about laying tracks. It was about threading a needle through nature's most complex tapestry. The construction strategy was unconventional. Engineers decided to build from both ends of the route simultaneously, tackling the easier sections first before finally converging on the central, most formidable segment. The initial breakthrough came with an 87-mile section from Chengdu to Yan, where the relatively manageable terrain allowed trains to reach speeds of up to 124 miles per hour. This segment not only bolstered local travel, but also served as a critical proving ground for the ambitious project ahead. As the railway pushed deeper into the Tibetan heartland, the true scale of the challenge emerged. The central section of the route, extending over 250 miles from Lhasa to Ningyi, navigates an unforgiving terrain that appears, at first glance, almost otherworldly. Here, the landscape is defined by staggering altitudes. Most of the track runs at over 10,000 feet, with a significant 90% of the final stretch soaring above 9,800 feet. This section is punctuated by dramatic engineering feats. 47 tunnels have been carved through solid rock, and 121 bridges have been constructed to span deep gorges and roaring rivers. Among these, the Zhangma Bridge stands out, a 1,722-foot-long structure, renowned for being China's first weather-resistant steel bridge built without any protective coating. Its design and construction symbolize the audacity and innovation that have become synonymous with this project. Yet, with every mile laid, the railway faces nature's most daunting obstacles: steep elevation changes, unpredictable weather, and an environment where even the air grows thin. Engineering in such extreme conditions demands not only robust infrastructure, but also revolutionary technology. To safely traverse the Tibetan Plateau, specialized high-altitude trains were developed. The CR-200J Plateau, engineered specifically for this environment, features advanced oxygen distribution systems and measures to combat altitude sickness. While these trains operate at a slightly reduced speed of around 100 miles per hour compared to other sections of the network, their design is a critical adaptation, ensuring the safety of both passengers and cargo under some of the harshest conditions on the planet. The project's ambitious design goes beyond mere track laying. It represents a convergence of modern engineering and ancient landscapes. By integrating advanced tunnel boring machines and employing a strategy of simultaneous construction from multiple points, the engineers have redefined what is possible in railway construction. Historically, Tibet's development has been hampered by its isolation. With limited transportation options, The cost and risk associated with moving goods and people have kept the region on the margins of rapid economic growth. Conventional road networks, such as the famed Sachin-Tibet Road, a 1,240-mile route known for its breathtaking yet treacherous scenery, offer little relief, often requiring more than 40 hours of travel in hazardous conditions. The new railway, however, promises to revolutionize connectivity. Once completed, it will provide a faster, safer, and more efficient alternative for cargo deliveries, reducing reliance on expensive and risky air transport. In 2021 alone, Tibet attracted 41 million visitors, generating over 44 billion yuan, or about $7 billion, in tourism revenue, with the railway dramatically cutting travel times. For a region where economic advancement has long been stifled by geographic and environmental constraints, this project is more than a transportation upgrade. It is a beacon of hope for future prosperity. Eastern Tibet is not only a landscape of dramatic beauty, but also one of significant geological instability. The region is marked by high seismic activity, a consequence of the Indian tectonic plate pushing under the Eurasian plate. In 2008, a devastating earthquake in Sachin, with a magnitude of 8.0, claimed 69,000 lives, injured 374,000 people, and left millions homeless. This seismic event triggered approximately 200,000 landslides, underscoring the enormous natural forces at play. Such risks have necessitated a cautious approach throughout the railway's construction. Originally slated for completion by 2025, the deadline for the most challenging central section was later extended to 2030. This extension reflects not only the technical difficulties inherent in building across unstable terrain, but also a commitment to safety and precision. Every decision, every engineering calculation, is weighed against the possibility of natural disasters, a reminder that even the most advanced technology must respect the formidable power of nature. As the project continues to advance, its implications reach far beyond the boundaries of Tibet. This railway is poised to become a critical artery for the region, redefining trade routes and transforming the lives of those who live in one of the world's most isolated regions. By significantly reducing travel times and opening up new channels for economic activity, the railway is expected to serve as a catalyst for broader regional development. In many ways, the project represents a blueprint for future infrastructure initiatives in extreme environments. It demonstrates that with innovation, careful planning, and unwavering determination, even the most inhospitable landscapes can be transformed into thriving centers of connectivity and growth.